All right, guys, welcome back. All right, so in the last video, we took a look at sequences. We figured out what sequences were, and specifically, we figured out how can we tell if we have an arithmetic sequence, right? And we determined that we knew we had an arithmetic sequence if we had a constant rate of change or a constant difference, all right, between terms in our sequence, okay? So the next thing that we're going to do is we're going to figure out how do we describe an arithmetic sequence mathematically. All right, so let's take a look at a sequence. All right, so I'm going to put down some values here. We're going to start at 6, and then 11, and then 16, and then 21, and then 26. All right, and we'll continue from there. All right, so remember again that those three little dots are called ellipses. All right, and they basically indicate that the sequence continues off to the right. Okay, so I guess the first thing we have to ask ourselves is this an arithmetic sequence? Well, let's take a look, right? Let's take a look at the differences between terms. All right, so we have between 6 and 11, we have plus 5. Between 11 and 16, we have plus 5. Between 16 and 21, we have plus 5. All right, 21 and 26, we have plus 5. All right, so we're good. We have an arithmetic sequence. All right, so the next thing that we need to do is then figure out, well, how do I describe this sequence, right, with an equation? All right, so before we get into that, let's talk a little bit about how we refer to sequences and terms in the sequence. All right, so one of the things we're going to do, and I'm just going to pop this off real quick, erase that. All right, so one of the ways that uh, values or terms in a sequence are named, all right, is by using a special kind of notation. All right, so let's do this. All right, so I'm just going to graph this out real quick, or just put a table here real quick. All right, all right. So let's say that our first term we're going to call 1, right? That makes sense. The first term should be labeled number 1, right? Our second term should be labeled number 2, our third term 3, fourth term 4, fifth term 5, etc. Okay? Usually when we are referring to members in a sequence, we talk about the nth term, n, as in Nancy, okay, or number. All right. So the nth term, right? So if we're talking about the second term in our sequence, we would be referring to the 11. If we're referring to the fifth term in our sequence, we would be referring to the 26. All right. So each member of our sequence has an n value. Okay. Which value is it down the line? Okay. And then we refer to the sequence itself with some kind of some kind of a letter. All right. So the name of our sequence, let's call it arithmetic sequence. So we'll call it A. Okay. And then in terms of naming the value itself, we use a sub n. So an n is basically, or a sub n is basically a letter. The nth term, right, is placed kind of below and to the right of the name of the sequence A. All right. So think almost in terms of, like, when we deal with like an exponent, we write it that way. All right, where that's the exponent. All right. This is also called a superscript. Superscript. Okay. Well, if I have something like this, a n, all right, this is sometimes called a subscript. Now, these, don't get the two confused. They have, all right, these are completely different. Okay. This means that I'm multiplying x by itself. All right. This means that I'm naming a term in the sequence. All right. So we shortcut that as just sub. All right. So that's a subscript and a superscript. All right. So just so you're aware of how that how that works. All right. So if we talk about naming a term, okay, we talk about, well, what is the third term of the sequence? Or what is a sub 3, right? A sub n, right? What is a sub 3? Well, a sub 3 in this case would be 16. So we can write something like a3 equals, or a sub 3 equals 16, right? That's a perfectly legitimate way of writing um, the value of that term. Okay, think of it almost like function notation. It's very very similar to the f of x kind of thing that we have kind of encountered over the last few weeks. All right, so that's all we're doing is we're naming our sequence and we're naming the terms in our sequence. All right, we need that notation so that we can figure out how to create the equation, all right, that goes along with our sequence. All right, so let me just get rid of this a little bit, and we'll go back to naming or describing our sequence. All right, all right. So um, there's a couple of ways that we can figure out the equation behind an arithmetic sequence. Usually, the easiest thing to do, right, I think, is to say, okay, well, the sequence, right, the individual values in each sequence, so a sub n equals, okay, and we're going to we're going to start at a specific value. So a sub n equals the first value of the sequence, we'll call it a1, okay, plus what is our rate of change? All right, well, our rate of change is that constant difference between values. Some textbooks use a D, for difference. I like to use K because it just doesn't look like anything else, right? And it's that constant, right? Even though constant is spelled with a C, um, I like to use the letter K to represent constant. Can we use any letter we want? Of course we can. It doesn't matter what letter we use. But I just like to think of it in terms of that constant K value. Um, so that we can figure out what our constant difference is. Okay, it goes back to the slope, right? What's the slope of the line, right? Some people use m, some people use k. Doesn't really matter. Okay, so it's the first term of the sequence plus the slope, or the constant difference, all right, between values, times the number of the sequence that we want minus 1. All right, so if I'm looking for, well, let me just write this in and then we'll describe it. Okay, so this is the general, right? This is the general equation, all right, of an arithmetic sequence. Okay, so it's a sub n equals a sub 1, the first term of the sequence, all right, plus the constant difference times n minus 1. Okay? All right, so let me just mark these in. First term. Okay. This is the, what do we say? This was the constant difference. Constant difference. All right, and then n minus n, right, is the n is the sequence value, the term name. Okay, term uh, term, yeah, we'll call it term name. All right, it's the number of the term in the sequence. Okay, so that's the general equation of an arithmetic sequence. All right, the general equation. All right, so let's take this, all right, let's take this and describe this sequence that we have right now. All right, So again, we are going to start with a sub n, and again, we can use a sub n, we can use p sub t, we can use q sub r, whatever we want to name our sequence and whatever we want to name our terms is completely up to us. Um, you know, uh, but for this problem we'll use a sub n. All right, so don't be confused by letters. All right, letters are just they're just names that we give things. All right, so a sub n equals, what's our first term? Well, our first term, all right, is 6. Right, so it's going to be a sub n equals the first term 6 plus, then, right, what is our constant difference, right? Well, we decided that our constant difference was going to be plus 5. So 6 to 11 was plus 5, 11 to 16 was plus 5, etc. All right, so 6 plus 5 times what? Well, we're not identifying a specific value yet. We're not identifying a specific member of the sequence yet. We're just describing every member of the sequence. All right, so we're going to leave this as n minus 1. All right, so the um, description of our arithmetic sequence is simply that. Okay, a sub n equals 6 plus 5 times the quantity of n minus 1. Okay, good so far. All right, the next thing that we're going to do is now we're going to test our equation. Can I identify one of the members of my equation? All right, does this equation work? All right, so let's say that I'm looking for the third member of my sequence. All right, I'm looking for A3. Okay, so what is A3, right? Well, we're going to follow along, all right, and basically copy the equation as it is, right? So A3 equals the first term 6 plus our constant difference 5 times, now because I replaced, right, similar to function notation, because I replaced an n with a 3, anywhere in the equation where there's an n, I'm going to replace it with the number that replaced the n. Okay, so I'm going to replace that with 3, okay, minus 1. Do some math here. All right, 6 plus 5 times 3 minus 1 is 2, right? So I have 6 plus 10 equals 16. So a sub 3, right, if we did everything right, should equal 16. We go up to our table, right, and sure enough, a sub 3 equals 16. So in terms of describing an arithmetic sequence mathematically, that's what we have. All right, let's try one more with a different sequence value. All right, and let's try this one. All right, so we'll start at, where can we start? Let's start at 13. All right, and let's go from 13 to, where can we go? We can go to 5. We can go to -3. We can go to -11. All right, negative 19. Okay, so what does this look like? All right, so do we have an arithmetic sequence, right? Is that what we're describing so far? Well, let's take a look. From 13 to 5 is -8. From 5 to -3 is -8, right? We're subtracting 8 each time. It looks like we have an arithmetic sequence, so that seems to work. All right, so we have an arithmetic sequence. We have a linear sequence. All right, let's name our sequence, right? Let's table this up. Okay. All right, so the first, so the nth term, right? This is our first term. This is our second term. This is our third term, fourth, fifth, etc. Okay. We'll call our sequence again, whatever we want to call it. We'll call it, what do you guys want to call it? We'll call it T. Why not, right? So then each member of our sequence will be referred to as T sub n. Okay, good so far. All right, so let's write the general equation for an arithmetic sequence, right? So in this case, it's going to be, t sub n equals the first term of our sequence, right? T sub 1, right? Plus the constant difference, we'll call that k for now, right? Times n minus 1, right? So that's the general form, all right, of our arithmetic sequence. That's the general form of the equation for an arithmetic sequence. All right, so now let's translate that using the values that we have, right? So for this one, t sub n equals our first term, which is 13, okay? What is our constant difference, right? Well, our constant difference we had decided was negative 8. All right, so we're going to put in 13 minus 8, right? That's our constant difference. So even though it says plus k here, right, it is a negative value. The difference is negative, right? So we're going to put in a negative 8 there times n minus 1, okay? N being the term number. All right, good so far. All right. So let's see if this actually works. All right, let's say that we want to find out what is the fourth term of our sequence. What is t sub 4? All right, so we're going to put in t sub 4 equals, right, let's write in the values that we have, 13 minus, okay, 8 times, well, remember that I replaced the n with a 4, so anywhere that I see an n in my equation, I need to replace that with the same value, 4, right, minus 1. Okay, do a little math. 13 minus 8 times 4 minus 1 is 3. All right, gives me 13 minus 24 gives me a negative 11, right? So according to our equation, t sub 4 equals negative 11. And hey, look at that. In our table, right, the fourth term in our sequence is negative 11. All right, so there you go. Describing arithmetic sequences mathematically is actually pretty simple. All right, it's always going to be the sequence itself, right? So the each member of the sequence is going to equal the first term of the sequence plus the rate of change, all right, times n minus 1, all right, the number of the sequence minus 1. All right, so there you have it, describing arithmetic sequences mathematically. Pretty straightforward. In the next video, what we're going to do is we're going to take a look at how to graph these things. All right, so go help your parents shovel the driveway a little bit, and then come back and we'll finish up this section. All right, by graphing our sequences. All right, see you in a bit. Bye.